Okay, I'm just going to make a little flipped lesson going through this vector stuff. So vectors are a way of representing a number or a quantity that both has a size and a direction. And sometimes instead of the word size, we use the word magnitude. So hopefully in year 10 you talked about the difference between distance and displacement, which is when you're talking about how far something moves. Distance, the direction is important. Displacement is, it has a direction. You talked about the difference between speed and velocity. So velocity has a direction. It's a vector quantity as well. And things like acceleration and force and momentum when we get to it are also vector quantities. So the direction is important. So it has both a size and a direction. And we represent a vector with an arrow where the length of the arrow represents the size or the magnitude, and the direction of the arrow indicates the direction that the quantity is acting in. So just as an example here, this vector here represents 4 newtons, so it represents a force. We can tell that from the units, and it's in the direction of east, and that's using our standard northeast, southwest compass type directions. And if you like, our scale here shows that's 1 newton. Because it's 4 times the line of length of that scale line, then it represents 4 newtons. So yeah, displacement, there was a bit of confusion, I think. Some people thought we could only use a vector to refer to a distance or a displacement. A vector can refer to a displacement, it can refer to a velocity, it can refer to an acceleration, it can refer to a force. Any of those things have both a size and a direction and can be represented by a vector. So we need to know how to handle vectors. The probably easiest thing that we do is vector multiplication. And basically, if we are multiplying a vector by a positive number, then it just becomes equal to the length. So if that is A, if we have 4A, we multiply that by 4, that will be 4 times the length. It'll be still in the same direction, but it will be 4 times the length. If we multiply it by a negative number, that means it will go in the opposite direction. So if this vector here is A, if we multiply it by minus 1, so it becomes minus A, we get the same length vector, but in the opposite direction. When we add vectors, we basically do something called the tail to tip rule. So if we have the vector A and the vector B, and we want to add them together, we draw in A first. We could do B first. B plus A will equal the same as A plus B, but we draw in A first, and then we add B to the tip of A, and then we draw a line from the tail of A to the tip of B, and that gives us A plus B, and I'll go through some of these in a sec. Subtraction of vectors is a little bit tricky, but I think it makes sense if you've got a bit of an understanding of numbers. If we want to know what A minus B is, we can algebraically almost rearrange that to A plus minus B. A plus minus B is the same as A minus B. Hopefully you understand the basic algebra and sign rules and that sort of thing that you would have learnt in junior maths classes. So if we want to know the difference between A and B, A minus B, we go A plus minus B. What does that look like? Well, we take A, we take A, and then we add on to it minus B. So if this was B, minus B would go in the opposite direction. So probably strictly speaking here, you could say, in terms of my notes, I should put a minus there. That's going over the line. Don't really like the look of that. Hang on a sec. To undo a minus B. So that becomes A plus minus B. And that's how we deal with a subtraction. So we basically turn the subtraction into an addition by making B into minus B. This all related to vectors in 2 dimensions. So if you like, we're worried in the X and the Y. If we've just got vectors in what we call 1 dimension, which is basically just along a line, we can just handle them basically using a normal number line and arithmetic. So basically one direction is positive, the other direction is negative. So yeah, if we're along a line, we're dealing with forwards and backwards. If we make forwards positive, backwards negative, and then we just deal it with like normal directed number type stuff. Hopefully you all know that by Year 12 physics. But if you're not sure about that, please do sing out and ask. I just don't want to make this flip lesson too long. Okay, so I'll really just go through now question 1, what you needed to have, what I was expecting. Sorry, if you're watching this video and you haven't done these questions yet, have a go at these questions first. So this is the spot where you pause the video, make sure you've had a go at the questions, and then keep watching the rest just to check your answers, or if you're stuck and you're not sure what to do. So, first one, A plus B. So A goes 4 squares across like that, that's A. And then we add B onto the tip, and B goes down 5 squares, so it goes down like that. So that's B. So the answer, if you like, the sum of those two is A plus B. And for this question, that's all you need to do. Further on, if we had numbers and that sort of thing, that's when you'd need to use some algebra and some things like that to solve that more. So if we look at B plus C, B, we just had that before, goes 5 squares down. That's B. And then C goes 4 across and 3 up, which I think is there. So that is C. So C gets drawn onto the tip of B. And then the answer goes from the tail of B to the tip of C. So that's B plus C. Question C, 2A, which is basically the same as going A. That's only 3 squares, that's 4 squares. A plus A. It's a bit harder to draw this one. That is effectively going to be that. Or you could have just done double the length of the line A to give you A plus A. This is where your one-dimensional stuff comes in. You really hardly need to go to vectors. Then we have B plus 2F. You've got to be a little bit careful how you draw these. So I'm just going to start maybe down a bit, and I'm going to go B, which is 1, 2, 3, 4, 5 squares down. And then F, which goes to 1, 2, hang on, 1, 2, 3. So 3 and 3. So from the, there's B, and then we have F, 1, 2, and then we've got 2F, so twice the length, like that. And then the total starts from the tail of B and to the tip there. So that becomes B plus 2F. And then if we go on to the minus F, that is just, I won't even do the F in there. Minus F is just going to be same length, but in the opposite direction. That's minus F. And then we've got minus 2C. So minus 2C is going to be same length but the opposite direction as C, and it's going to be twice the length. So that's the one that goes 4 and 3 across. So I'm going to go 4 across, 3 up. So I've got to go 3 down and 4 across. So that's going to give me minus C, and I'll just use my rubber here because obviously I didn't really actually want to put that on there. So you probably hear the dogs going crazy outside. And what you can't see is my dog running around all over the top of me as well. Sorry, hang on. I have stuffed that one up. Let's do it properly. I've got to start here. I've got to go 3 down and 1, 2, 3, 4 across, and then another 3 down and 1, 2, 3, 4 across. So that's going to give me minus 2c. Then we get into a subtraction one, a minus b. So we will start off here with a, which will go 4 across, and then we are going to go minus b, so it'll be 5 long, but instead of going straight down, it'll go straight up, like that. So that gives you a resultant here, a minus b. So what have I done there? I've gone a plus minus b to give me a minus b. And then we've got b minus a. So a plus b and b plus a are always the same, but it's not quite the same if you're doing a minus b or b minus a. So if we come down to here, we start with b. And I'm just trying to keep in my mind which way these are going. I think if I start here, that'll be right. There is b, and then minus a is horizontal, but instead of going to the right, it goes to the left. So that becomes minus minus a. Just fix that. Oops, went too far back. That becomes minus a, and the resultant again starts at the tail of b and goes to the tip of a, and that becomes a minus b. Sorry, did that wrong. B minus a. B is straight down, and then A, we've gone the other direction. Sorry, hope I'm not making it too confusing. Then we have E minus C. Let's have a look. E, oops, yep, that's fine. E goes 4 down and 1 across. So we start here and go to here. That's E. And then C would go, that's the one that goes 3 down, 4 across, but instead of sort of pointing a bit upwards, now we're pointing in the opposite direction. So minus C is going to go 3, 1, 2, 3, 4. That will be minus C. And that there will be E plus minus C, or E minus C. Getting a bit squishy there, sorry. And then finally we can still do this with 3 vectors, A plus C plus E. So we go, A is the one that goes 4 across, and then C goes, I'm going to maybe run out of room here, 4 across and 3 up. So that's A plus C. And then E goes 1 across, 4 down, which takes us down to here. And again, here we go to the tail of A and we go across to the tip of E, which was our last one. So it's not drawn really clearly, but I think you see what's happening there. Plus, that was A plus C plus E. And then we have E plus C minus B. So that's going to be E plus C plus minus B. Hopefully I've got room here. So we're going to have E, C, minus B. So I think I want to start down here somewhere. We start with E, go back to red for our component vectors, so the ones that make it up. There is E, and then we're going to add C, which is the 4 across, 3 up. So that's C, and then we're going to add on minus B. So B would go 5 squares downwards. We're going to go 1, 2, 3, 4, 5 squares upwards. We almost end up in our other one. And then our total goes from the tail of E to the tip there of, sorry, I forgot to label that one, minus B. So that becomes E, oops, wrong colour, E plus C minus B. So that's what each of the solutions for that question should look like. Hopefully that's what you've got, but if you didn't get that, hopefully it makes sense to you what it should be. Okay, I'll move on to the next, to the final page. So again, if you haven't done these questions yet, please pause the video, have a go at these questions, and only use this once you've had a go and either can't do it or you've had a go, done them, and you want to check your answers. So Tom and Kate are both pulling on Jack. Tom is pulling with a force of 30 newtons north, while Mary pulls with a force of 40 newtons west. Determine the resultant force on Jack. So here we've got two forces acting together. We're after an addition. We're looking for a resultant force. What's the total force? So, very simply, just to label it out, we can just use sort of 1 square equals 10 newtons. And we know that Tom is pulling with a force of 30 newtons north. So, north, we use generally that north is the top of the page. Never eat soggy Weet Bix. So that is the force due to Tom, which is 30 newtons. If I had more room here, I'd probably write it out a little bit clearer, but I think that gives the idea. And then Mary pulls with a force of 40 newtons west. So to the west, 4 squares for 40 newtons, and that's Mary. Now, I think I see a few people when I look at people doing these who sort of skip almost this step. This is like the writing the information down in the question step. It's a really important step. Those of you guys who've had me before will have heard me rabbit on about this. So now we realise that we want to know the total force, so we've got to add those two together. So this is where we're going to do our vector addition. And I'm going to draw these vectors in again. We have 30 north, that's the force due to Tom. And then we have, now, and this will happen to you guys as you do it. What I've just realised is I've drawn the not far enough across. And when I come to add the second force on, my diagram doesn't work. So I'm just going to rub it out and start again. So yeah, we have 30 north, and then we have 40 west, and the total force, I can draw better than that, the total force will go there like that. How do we work that out? Well, we can see there that's a right angle triangle. Hopefully you've done enough maths that you know that 3, 4, 5 is a Pythagorean triplet, but if not, you could go 30 squared plus 40 squared, and you would get 2,500, and the square root of 2,500 would be 50. So the magnitude of that force, the size of that force would be 50 newtons. And then you would need to work out the direction, and I've just realised I haven't got my calculator here with me to do this, but what you would need to do is then just use some trig, and there's lots of different ways you can do it. I would probably find out, if it was me, let's use a different colour, this angle here, and because I like using sine, I'm going to go sine of theta equals opposite which is 40, over hypotenuse, which is 50. And then if I do the inverse sine function, I can work out what theta is, and I'm just going to pause and go and find my calculator. Okay, yep, I'm back and we're recording. I put that in the calculator, I make sure it's in degrees, not radians mode, and I get 53.1 degrees. So that to me is saying if we go north and then we come around to the west, that is that angle. So I would describe the total force there as 50 newtons, and the direction would be north, and then we're coming around 53.1 degrees towards the west. So we're going north, and then we're coming around to the west. Oh, use this north, and we're coming around to the west, 53.1 degrees. So that would be the answer there. So next one, Emma tries to row west across a river in which the current is 2 metres per second, which a current of 2 metres per second south is flowing. If she rows at 3 metres per second, what is her velocity relative to the bank? So we've got two forces. We've got two forces acting. One is she's the rowing force, which is trying to push her west. The current, which is flowing south. So the direction is going to be the resultant of those two. So we are going to have, if you like, doing the setup for the question again. And, you know, if you get really good, maybe you can almost skip this, but let's use it when we're starting out. She is trying to row at, and I'm going to use a bit bigger scale this time. So for 3, I'm going to use 6 squares. So she's trying to row at 3 metres per second west, and the current is flowing south. So I'm almost going straight to the answer, but I'm going to resist that urge. 2 metres per second south. So I'm going to make that 4 squares. So 2 squares equals 1 on my scale. I could put my scale on there if you wanted to, but probably don't need it. So when I add those two things together, we get that's 6, yep. That is the velocity due to the rowing. We add on the velocity due to the current. So we have a 3 and a 2. This blue vector represents our total. So we use our Pythag here. So the length of this line is going to equal the square root of 2 squared plus 3 squared. So that is going to equal 4 plus 9. So that's going to equal the square root of 13. I'm not fussed if you leave that at the moment as square root 13, or you put it in your calculator and work it out. And the direction, I'm probably going to work out this angle in here, because it's going to be west so many degrees south that she actually goes, because of the combination of the rowing and the current. And I can use my Pythag. I just like using sine because I've got all 3. So I'm going to go sine theta equals 2 over root 13. A lot of people might have used tan because that's the one that they've got, but it doesn't really matter. Do a shift sign on my calculator, and we work out that turn my calculator back on. Shift sign 2 divide, I'm using a new calculator, I can't find the square root button. Oh, there it is. 2 divide square root of 13 is equal to 33.7 degrees. So the total velocity there would be, and just for those who do like to work these out on the calculator, I will go clear, I'll go square root 13, 3.6. So it would be 3.6 meters per second at west 33.7 degrees south. So west and then going around 37 degrees to the south. In the next one, we have a similar question. Airspeed of an airplane is 900 kilometres an hour and is fly west at 100 into a 100 kilometre an hour breeze. Sorry, it is airspeed of a plane is 900 kilometres an hour and it is flying west. There's a grammar mistake there. Into a breeze from the southwest, determine the speed of the plane. So we have our plane going, how'd I go at guessing 9 squares? 1, 2, 3, 4, 5, 6, 7, 8. I've got 8. That represents how 900 west. But we've got a breeze from the southwest. So if it's from the southwest, it is basically going to be going back up this way. And it's going to be 100. So from southwest means it's actually going to be pointing towards the northeast. Not that you have to put the direction in there, but you could if it made you feel better. But that's just, we're just writing down the information in the question and picturing it. So then we add those two things together. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I've got to write that time. And then obviously the 100 is much smaller than the... And then that gives us basically the direction that the plane would be going, the total. If you want to work that one out, it becomes a little bit more tricky in that you've got the information here that you've got is 900 on this side, 100 on this side, and there is your A plus B. Now, anyone here who's got reasonably competent... and we also know that the angle in here, because it's northeast, would be 45 degrees from this. That's at 45 degrees. That angle of the wind is at 45 degrees to the direction of travel. Now, you can't use right angle trig there. It's not a right angle triangle, so you can't use your simple SOHCAHTOA. You need to either use the cosine rule or the sine rule, and if you know what those are, you'll know what I mean. But you don't get given those in physics. So the other option, and you have this option in every question, but I put this one in there just to highlight, is you have the option to use a scale diagram. And it can be quite rough, that scale diagram. You'll also notice in this question that it only asks you for the speed. So we don't actually have to work out the direction. Before, it was a velocity. So velocity has a direction. Force has a direction. We needed both. So you can tell from this scale diagram that this is going to be, that 100 is not going to go right across the square because the diagonal of the square would be like root 2, so it'd be like 140. So it's going to be a little bit shorter. So this is going to be just over 800. And if you got a ruler out and measured everything, you might do a bigger one. You should get to an answer of about 800, and I'm just guessing here, I haven't gone and checked this one, but about 810 kilometres per hour. And that would be sufficient. You would get the marks there. That would be all that you need. I've sort of put that one in there to highlight that you could use a scale diagram. You should use a ruler, which I haven't done there. In fact, now that I think about that, 1.4 might be better at 820 kilometres per hour. But honestly, in scale diagrams, there's a reasonable tolerance for what you can do. So that's another option. Okay, into question 5 and 6. 5 and 6 are a bit different. And the key reason that they are different is they are talking about a change in velocity. A change in velocity. When we are talking about change, we are talking about subtraction. I know we talked in class and not everyone had sort of was familiar with that, but change is one of those key words that says how much change do you get when you buy something? Well, it's a subtraction. You subtract the amount you gave them off the price, and that's the amount of change you get. So when you see the word change, always be thinking subtraction. So we have a car travelling 40 kilometres an hour west, going around a bend, and then heads 30 kilometres per hour south. So, if we were going to draw a little picture here, we can think about the car going west and then turning and going south. So what is the change in velocity? We start off, let's just do 1 square, 40 west. We go finally at 30 south. That was west. We're going to do a subtraction. So we are going to go, if you like, delta V, which is change in velocity. We use the triangle, which is the D from the Greek alphabet, for difference, which is another word we use for subtraction. What's the difference? Equals VF minus VI, the final velocity minus the initial. We can put a little arrow there to realise that they're vectors. Well, that's going to be equal to VF plus minus VI. So I am going to start off with a VF and draw that in. That there is, so let's label this diagram here. That was VF. That was VI up there. So VF, and then I am going to add on minus VI. So I'm going to go 40 in the opposite direction. So we've got a 30 and we've got a 40. You're probably seeing here we've got another Pythagorean triplet. 30 squared is 900, 40 squared is 1600. 900 plus 1600 is 2500. The square root of 2500 is 50. So that gives us the speed, if you like, the change in speed is 50 kilometres an hour. So yeah, we don't go 40 minus 30 equals 10 because the direction is important. If you're running forwards at 10 metres per second, then you turn around and run backwards at 10 metres per second, 10 minus 10 is 0. Your change in velocity is not 10 metres per second. Because you were going in one direction and then you're going in the opposite, it's like going 10 minus 10, because the opposite direction, opposite sign. 10 minus 10 would be 20. So your change in velocity, if you went from running 10 metres per second forward to 10 metres per second backward, would be 20 metres per second. So that's why you get maybe a bigger number than you're expecting, but that's the right answer. And then we can work out the angle again here. I would probably go from south around to the east. So I want to know that angle in there. And if I go sine theta equals the opposite, equals 40 over hypotenuse, which is 50. Theta would therefore equal 53.1 degrees. So the total velocity there would be 50 metres per second at an angle of, what did I say, south 53.1 degrees east. Going back to our scale that we had up here. Hoping that makes sense. So last one here is ball travelling at 10 metres per second, bounces off a wall with no loss in speed. What does that mean? when it bounces off, it's still going 10 meters per second. As shown in the diagram, calculate the change in velocity of the ball. So this is V, oops, I'll try and stick with my original colour scheme. VI equals 10, VF equals 10, delta V, change in velocity equals VF minus VI equals VF plus minus VI. So that means I've got my VF and I'm going to add my VI onto it, so onto the tip of that, and it's going to be the same length as VI but in the opposite direction. So it's going to come back here like that, minus VI. And then when you add those two together, you get that there being the change in velocity. Now you could use a scale diagram and measure the length of the lines there. You can see that, to me, those two lines, you know, it's going to be horizontally away from the wall, but if you draw that out as a scale diagram, it'll show that. We could also work out, well, this angle here is 30 degrees. The length of this side is 10. The length of this side is 10. So it's a isosceles triangle. I think I've got my terminology right. So that's also 30 degrees. Again, if you know the cosine rule or the sine rule, and you know that side is 10, you know this side here is also 10, you could work it out directly. Or if you don't remember that, you just remember your right angle trig. You can put a line through the middle there, which is 90 degrees. And so the length, if you like, of just that bit, so half of that line, would be equal to, we know, we're going to need to use the cosine rule here, because we know the, okay, I've got the right pen, that the cosine of 30 will equal the adjacent, which is what we want to know, divided by the hypotenuse, which is equal to 10. So A is equal to 10 times by the cosine of 30, which is equal to, press the right buttons, 10 times cosine 30, which is equal to 8.66. And then so the change in velocity is basically equal to 2 times that. So 2 times 8.66, which is equal to 17.3 meters per second. And that is directly away from the wall or perpendicular away from the wall, horizontally away from the wall. There's lots of different ways you could say that. I would even accept that if you just drew an arrow that showed that that was clearly horizontally in that direction away from the wall. As I said, as long as you clearly communicate that direction, that's fine. Okay, so that's gone through all of those questions. Hopefully everyone feels like they understand what they need to do there now. And we're ready to launch into the first topic. Cheers.